Okay, so in this video, I'm basically gonna talk about planes. So what's a plane actually? You can think of it like a dimension, technically like a two-dimension set of maybe like a wall inside a room. You can think of that as an example of a plane like this. So maybe let's say I have some sort of a cube like this. So you can basically see that the fourth side of that, will technically be more of a plane. That so here what we are interested in is finding the equation of that plane. We're interested in finding the equation of a plane, and a plane doesn't technically have boundaries or its limits in that, so you can continue indefinitely. So here I'm just gonna draw that because like we want something to be defined. You cannot draw something that's of infinite size. So now what you need when you find the equation of a plane is that you need 3 points. You're gonna need 3 points, and those 3 points mustn't be collinear. That means like if you have 3 points that are in a linear system like this, you cannot find the equation of a plane. You need 3 points that are like this. Technically they must form a triangle, and then from then you get a normal vector, or from that, or a vector perpendicular to that plane. And then when you dot a normal vector and some change in coordinate system set p minus p naught, okay, let me just write it like this. Let's say the normal vector dotted with some vector obtained from that. So let's call it vector v that lies on that plane from xyz to some point, let's say point A like this, and then we have point B, point C, and then we have some point P, and that point P, let's say it's denoted by x naught, or let's just say x, y, and z instead of using subscripts in that. So PA will be our vector there, which I'm going to denote it with the vector v. The coordinates of A will be given. Then when you dot these two, you're going to technically get 0. So that's the dot product rule, since n will be perpendicular to that plane, will be perpendicular to that, will be orthogonal. It's technically the term they use there. So now let's say we have a plane passing through the points A 1, 5, 6, B 2, 5, 3, and then we have a point C, let's say 1, 2, 1. And then we have this 3 points. We have a plane passing through these 3 points. So what you're going to do is obtain vector AB. Obtain vector AB from this one. So you're just technically going to have vector AB in direction vector form is going to be 1, 0, and minus 3. So that will be vector AB. You can also get vector BC here. Or you can also continue and say maybe you want to use AC. So you can get vector AC as well. So it doesn't really matter what you do. Technically, you must have like a common point between those two vectors. So vector AC will technically be 0 and minus 3 and minus 5. Then now let's see. Now we cross the two to get the normal vector will be a cross of the two. So we'll have the cross of the two vectors I, j, k. Those are the directions. Then you have 1, 0, minus 3, and then you have 0, minus 3, minus 5. And then you use the diagonal rule to evaluate this one. So you already know how to evaluate determinants, so I'm not gonna do that. So you have minus 9i plus 5j minus 3k. So that's your normal vector. Write it in direction vector for minus 9, 5, and minus 3. So now you dot that with, let's pick point A. So now you're just gonna have n dot v to be equals to 0. So you have n dot v, which is 0. Now we want to find an equation of a plane, and our normal vector is minus 9, 5, and then minus 3. And then you dot that with a vector obtained by from A. So it will be x minus 1, y minus 5, and then z minus 6. So that will be equals to 0. And then you further simplify this, so you have minus 9x plus 9 plus 5y minus 25 minus 3z plus 18 equals to 0. So this will be your equation of a vector. Simplify that: minus 9x plus 5y minus 3z. Then you add the constants together. So you have 9 plus 18, which gives you 27. Then you subtract 25 there, you get positive 2. So this will be your equation of a plane. Or you can multiply by negative and obtain something like this: plus 3z minus 2 equals 0. Or you can rewrite it as 9x minus 5y plus 3z equals to 2. So that's how you can find an equation of a plane, basically. Try other equations and see if you can find that. So if you have a normal vector and a point, remember this is just technically a point obtained from A. So you only need a normal vector and a coordinate to get the equation of a plane. That's it.